Hello everyone, welcome to a journey into the future of energy, a future that's unfolding right now, all around us. Let's talk about energy, the invisible force that powers our homes, our cities, and the very devices we use every day. From the moment we wake up and turn on the lights to the late hours when city skylines glow, energy is the heartbeat of modern life. For decades, we've relied on fossil fuels like coal, oil, and natural gas to keep our world running. But their impact on the climate is undeniable. Rising emissions, polluted air, and a warming planet threaten our health and our future. The world is searching for cleaner, more reliable energy sources. Solar, wind, and hydroelectric power are making great strides, but they can't always provide energy when and where we need it most. Enter nuclear energy, specifically a new generation of technology, small modular reactors or SMRs. These innovative reactors are changing the way we think about nuclear power. Unlike the massive plants of the past, SMRs are compact, designed for safety, and can be built almost anywhere. Their flexibility means they can power remote towns, industrial sites, or even support existing grids. Countries like China and Finland are leading the way, reimagining how we power our cities and industries. They're investing in SMRs to create cleaner, more resilient energy systems. SMRs can do more than just generate electricity. They can provide heat for homes and factories, and even produce fresh water by powering desalination plants, all with minimal emissions and a tiny environmental footprint. Imagine a power source that works 24/7, rain or shine, day and night without producing greenhouse gases. SMRs offer a steady, reliable supply of energy, no matter the weather. While renewables like solar and wind are vital for a sustainable future, they need a steady partner to fill the gaps. SMRs could be that partner, ensuring our lights stay on and our industries keep running. That's why nations around the world are investing in this technology, seeing it as a key to solving our energy and climate challenges. SMRs could help us meet ambitious climate goals while supporting economic growth. Today, we'll explore how SMRs work, take a closer look at China's groundbreaking Linglong 1 reactor, and see how Finland is planning to heat its cities cleanly and efficiently, even during the coldest winters. We'll dive into the science behind these reactors, discover what makes them different, and learn how they're designed for safety from the ground up. We'll also look at the rigorous safety measures, the strict regulations, and the challenges that still lie ahead for this technology. This isn't just about machines or technology, it's about human ingenuity, collaboration, and our shared vision for a cleaner, healthier world for generations to come. Ready to see how small reactors could make a big difference? Let's get started and discover the dawn of a new nuclear age together. Scene transition. End of scene. So, what are small modular reactors, or SMRs? These innovative nuclear power systems are generating a lot of buzz in the energy world, but what actually sets them apart from the traditional nuclear plants we're used to seeing? First, let's talk about the small part. SMRs are much more compact than conventional nuclear plants. Sometimes the entire facility can fit on a site no larger than a football field. This smaller footprint means they can be built in places where large plants simply wouldn't fit, opening up new possibilities for clean energy. Despite their size, these reactors pack a punch. A single SMR typically generates up to 300 megawatts of electricity, which is enough to power a small city or a large industrial complex. And because they're scalable, multiple units can be installed together to meet growing energy needs. The modular aspect is just as important. SMRs are manufactured in factories, where quality control is easier to maintain. The modules are then shipped to the site and assembled much like building blocks, which streamlines the construction process. This factory-built approach means construction is not only faster but also more predictable and cost-effective. Delays and budget overruns, which often plague large nuclear projects, are much less likely with SMRs. But SMRs aren't just about generating electricity. Their versatility allows them to provide heat for entire cities, supply reliable power for factories, and even drive desalination plants to produce fresh water in coastal regions. Thanks to their compact size and flexible design, SMRs can be placed in remote communities, near urban centers, or even integrated into existing energy infrastructure. This adaptability makes them a promising solution for regions with unique energy challenges. And as energy demand grows, utilities can simply add more modules to the site, expanding capacity without the need for massive new construction projects. SMRs have the potential to help decarbonize not just our electricity supply, but also heating systems and industrial processes that are traditionally hard to clean up. safety is a top priority. Many SMRs use advanced passive safety systems that rely on natural forces like gravity and convection, reducing the risk of accidents and making them safer than older reactor designs. The result is a flexible, adaptable, and accessible form of nuclear power that could play a major role in the 21st century's clean energy transition. As we search for ways to meet our growing energy needs while cutting carbon emissions, SMRs could be the missing piece in our clean energy puzzle, offering reliable, low-carbon power where and when it's needed most. With their unique advantages and growing support, the era of small modular reactors may have finally arrived. Scene transition, end of scene. Let's head to China, a country at the forefront of nuclear innovation and energy transformation. Here, small modular reactors, known as SMRs, are no longer just a concept. They're becoming a reality, reshaping how the world thinks about clean, reliable power. The Linglong 1 stands out as the world's first commercial land-based SMR, marking a major milestone in nuclear technology. Built at the Changjiang Nuclear Power Plant in Hainan Province, Linglong 1 uses proven pressurized water reactor technology, but in a much more compact and integrated design than traditional reactors. All the key components, reactor core, steam generators, and safety systems, are housed within a single vessel. This not only boosts safety by reducing the risk of leaks, but also simplifies construction and maintenance. Linglong 1 generates 125 megawatts of electricity, which is enough to power over 500,000 homes, providing stable, low-carbon energy to growing cities and communities. But its capabilities go far beyond just generating electricity. Linglong 1 is designed to provide district heating for neighborhoods, supply industrial steam for factories, and even power desalination plants to turn seawater into fresh water. On Hainan Island, where fresh water is a precious resource, this technology will play a crucial role in supporting local communities and industries by ensuring a steady supply of clean water. China sees Linglong 1 as just the beginning. The country is planning to deploy more SMRs across cities and industrial zones, and even aims to export this technology to other nations seeking clean energy solutions. By building these reactors quickly and efficiently, China is setting a new global standard for nuclear energy deployment, showing the world what's possible with determination and innovation. The nimble dragon is ready to fly, leading the charge into a new era of safe, flexible, and sustainable nuclear power. Scene transition, end of scene. Now to Finland, where winters are long and heating is essential. Finland aims to be carbon neutral by 2035, and SMRs are central to their plan. Many Finnish cities rely on fossil fuels for district heating, but that's changing. The LDR-50, a low-temperature district heating reactor, is designed for safety and simplicity. It operates at low pressure, with passive safety systems that make it walk-away safe. These reactors could be placed near or within cities, replacing coal plants. Helsinki is exploring SMRs to decarbonize its heating network. By focusing on heat, Finland shows SMR's flexibility beyond electricity. Small local reactors could keep cities warm and air clean. End of scene. Traditional nuclear plants are giants, powerful but costly and slow to build. SMRs change the game with their smaller size, modular construction, and faster deployment. Built in factories, SMRs offer higher quality and lower costs. Utilities can add modules as needed, making planning easier. Safety is enhanced. SMRs use passive systems and generate less residual heat. They can stay safe even if external power is lost. Large reactors are like mainframes, powerful but inflexible. SMRs are like servers, scalable, adaptable, and efficient. This doesn't make big reactors obsolete, but SMRs open new possibilities for clean, affordable nuclear energy. They're a flexible tool for fighting climate change. Scene transition, end of scene. SMRs have promise, but challenges remain. Regulations were designed for large reactors, not modular ones. Rules must adapt. Early SMRs may be costly. Real savings come with mass production. Public trust is crucial. Nuclear accidents and waste concerns linger. Open communication and transparency are essential to build acceptance. SMRs still produce nuclear waste, and we need long-term storage solutions. Some designs can use recycled fuel, reducing waste. Managing the full fuel cycle remains a key challenge. Overcoming these hurdles is vital for SMRs to fulfill their potential. Scene transition, end of scene. Solutions are emerging for every SMR challenge. Regulators are collaborating globally to streamline approvals. Governments and investors are backing first projects to kickstart the industry. Public outreach is improving, with clear communication and community engagement. Emphasizing safety and climate benefits helps build trust. Advanced SMRs may burn existing nuclear waste, reducing long-term storage needs. Countries like Finland are building deep geological repositories for safe disposal. Combining innovation with responsible waste management is key. The roadmap is taking shape. SMRs are moving from concept to reality. End of scene. China and Finland's progress is inspiring a global SMR movement. The US, Canada, and UK are developing dozens of SMR designs. A global supply chain is emerging, driving innovation and lowering costs. SMRs offer a manageable entry point for countries new to nuclear power. They can replace coal plants, power remote regions, and provide clean water. For developing nations, SMRs could unlock economic growth and close the energy gap. As more countries join, investment and innovation accelerate. The first SMRs coming online will build global confidence. SMRs are becoming a collaborative international effort to reshape energy. End of scene. We're at a turning point in the fight against climate change. SMRs offer steady, carbon-free power, complementing renewables. China's Linglong 1 and Finland's LDR-50 show different but powerful paths. SMRs can be tailored for electricity, heat, water, or industry. Imagine SMRs powering hydrogen production, remote islands, or data centers. Their modular nature means they fit almost anywhere. The journey is just beginning. Challenges remain, but the direction is clear. With innovation, cooperation, and transparency, SMRs can help build a sustainable future. They represent a new, community-focused vision for nuclear power. Human ingenuity is at work, and SMRs could help power our world for generations. End of script.